We're going to show you how to do a test on a Massimo ISA CO2 module. This is the same routine that you'll do for the Massimo ISA anesthesia modules as well. Hit start. This tells us what gas we need for this module. Enter the asset ID of the device we're testing and our operator initials. This tells us what service manual this comes out of, and that this sequence is for the Massimo ISA CO2 module. So we'll start by doing an occlusion test. Touch start, and we'll watch the monitor for a message indicating that the sample line's plugged. We also watch the little ring around where the sample line plugs in to make sure that it blinks red. Also on the monitor it says replace sampling line. So we can say yes, next. Okay, next we're going to test the module for an internal leak. We have two methods to do that, and I'll describe both of them. By leak down method is the traditional method. I'll show you how that works. So we start by unplugging the module from the monitor, and then we plug the exhaust port. You'll have to silence the monitor. We make sure the sampling line is plugged into port A on the smart tank, and then we press start. The smart tank will pressurize the module. Once it has a stable pressure that's close to the target, it will start counting down time. So you can see here it's counting down a minute. Starting pressure was 112. This method obviously is time consuming because you have to unplug the module from the monitor, plug the exhaust port, wait for it to pressurize, and then wait a full minute for it to count down. So now that that's done, the next step we would do is the sample flow rate. So in this case, we plug the module back into the monitor, unplug the exhaust port, make sure that the module is operating, indicated by a green light around the sample line, and press start. The smart tank will measure the sample flow rate and compare it to the pass-fail criteria and return a value. So the flow rate was 56, and that's a pass. So now I'm going to go back, I'm going to navigate back past the leak test to the by flow method. So our by flow method runs the same sample flow rate test, but after it measures the flow rate, it switches a valve inside the smart tank that allows it to measure the difference in flow between the sample line and the exhaust line coming out of the module. And any difference in that flow gives us an exact reading of the leak. So here we'll show how quick that method is. It takes about the same amount of time to measure the sample flow rate, and then it just adds about 4 seconds to measure the leak rate. So there it's done. The sample flow rate was 55, fell well within the pass criteria, and the leak was less than the limit of detection, meaning the smart tank couldn't even detect a leak. And it was looking for a leak of 0.5 ccm, which is the same as milliliters per minute or less. So next we'll do the gas span check. So this is just an informational screen that tells us the module should be on and operating for at least 5 minutes, and that we need to make sure that the compensation, gas compensation, is set in the host monitor for the gas. So oxygen should be set to low or 21%, and nitrous oxide should be set to off. So we touch Cal on, which causes the smart tank to feed sample gas. It actually controls the flow of sample gas to limit how much gas is being spent. It only gives the module exactly what it needs and wastes the minimal amount through the vent. And then we look at the monitor. We should wait approximately 30 seconds for it to stabilize, and then the CO2 value will just enter in here. You see the expected value is 31.5. The smart tank calculated that value from the calibration gas that's installed in the smart tank and today's barometric pressure. You see we had 32, so they were reading very close to each other. So we can turn the cal gas off. And that's the end. We hit next and it generates a test report. You can scroll down and see everything about the test we just ran. Hit done to exit out to the main screen. We can go back and see that same test report by last report or all reports.